Hello, I'd like to show you today how we can use the method of increments to differentiate polynomials up to a value of 2. So I'm going to start with um, quite a standard one that you might have met when you first do calculus. You might come across this. So y equals x squared. Now y equals x squared is quite simple. It's one of the first ones you meet in class, but how do we differentiate using the method increments? So what we usually do if you have watched my other video on instantaneous velocity, it's the previous one to this one, relating to increments. So please watch that and it'll give you a better idea what's going on. But basically we want to give it a very small value, just a small value, but we won't actually give it a number, we'll just call it, if I show you, add delta y. Delta usually just means change, so or in this case a very small value. And we do so, we have to put the delta x in when we are doing the calculation. So let's expand it out. So y add delta y is x squared plus 2. Oops, that's a very long 2. X delta x. It's a bit confusing this bit because it's easy to get the x's. I don't know, I'm like thinking it's a normal x, but it's not. And then delta x squared. And there we go. So, and then what we'll do is, if you notice here at the top here, it says y equals x squared. So here we know this is x squared. So if we minus this, and we minus this too, so delta y equals 2x delta x plus delta x squared. Now, next stage is to divide by delta x. So we can see it. So in this case, this would be like trying to find the gradient. So the gradient here is this small value of y divided by this small value in x, which are like very small changes. And so this equals 2x plus delta x squared. Now as you can see here, you notice there's a 2x there, but there's this delta x squared, and you're probably wondering what do we do with that. Now, this is not really a cheat, but this is kind of a common thing in doing math. So we're not going to make it 0. So delta x is not 0. We've got to remember that. But what we'll do, we'll put a limit on it. And what we'll do is we'll put x approaches delta x approaches 0, and we'll just put delta y over delta x. And this means we can get rid of this basically. Actually, I should have, when I divided by delta x, I should have got rid of the 2, but doesn't matter. Same principle, and this equals 2x. So what we did, we increased delta x all the way to 0, or very close to 0, so we can eliminate it because it's just so small and insignificant, we don't have to bother about it. Now, as you can see here, this is the answer, and it looks similar to what you might have seen in class, but great. since we've done this, let's try it let's just go a bit simpler and see if we can apply the method of increments again, using this time just using y equals 5x. So it's not an x squared, but it's just an it's the order of polynomial 1. So y equals 5x, so let's do the same process as we did before. Y add delta y equals, when we do this, it's 5, open brackets, x, add delta x. And then what we'll do is, we'll expand it, so 5x plus 5 delta x and then what we'll do is minus the y, and this gets rid of this, so delta y, because this is a new sum pretty much, so I better not mess this up. 5 delta x. Now it's pretty standard here, so delta x y over delta x equals 5. Now we've kind of reached the answer on it anyway, but just so we make sure we put this in, delta x approaches 0. So, and there we go, that's 5. So as you can see, if it's got 1x in, just of order 1, then you just get rid of the x and it's just a coefficient. So let's go to the next one then. Let's do we'll just do a number this time, so y equals 4. So just with no coefficient of x at all, so x to the power of 0. Let's do the same principle. Now, interestingly enough, you don't put 4 add delta x, because there is no x to begin with, so it's just still 4. Now y equals 4, so delta y is 0. And you see here, so delta y over delta x. And if we increase the limit of delta x, it approaches 0. Oops. Equals 0. And there we go. Sorry, that was a bit messy, that one. So we can come up with a general formula for when we do this, so we don't have to keep doing this. So we kind of prove to ourselves that the method of increments works, but you know, we don't want to do this every time. So let's see what sort of pattern these have. So another way of saying you've differentiated y is putting like a comma here next to the y. 2x. I think the other one was 5x. And then differentiate that. It's just 5. And then y equals 4. Differentiate that, and that's 0. You might see a common pattern, so what you do is, in this case, and what you do then, as you can see here, so you take away minus 2, so it's minus 1 here, and then you take the 2 to the back. So we could write it like this: n minus 1, and that's the equation of the differential. Does it apply to this? Yeah, so 1 minus 1, and that's 0. So you get rid of the x, you can get rid of, and with 4, well, if it's x, so if we pretend there is an x there of x0, if we put the 0 to the back, then that equals 0, doesn't it? Whoa. So yeah, hope this makes sense. I hope it makes sense, and I thank you for watching. I hope I can make some more videos on calculus, because this is kind of a small little calculus course I'm going to try and do, so I hope it was useful. Okay, take care, bye.